recording. All right, so I welcome you again to this lesson. We are going to be looking at this topic, which is coming from Chemistry 1010 and Chemistry 1000. Okay, so this is significant figures and scientific notation. Okay, so I've noticed that in most times, okay, they don't teach this part at UNZA. They will just start at stoichiometry and then they will go like that. But these are the foundations that you need to know. Okay, so I've decided that, okay, I'm going to start my lesson from this. Okay, and if you've been following me, I also shared the lessons on how to convert units. So that's the very first topic that you should have both in chemistry and physics. Okay, so I shared those videos. I'm also going to share them after the lesson so that you can go through. And then in this lesson, we are going to be looking at significant figures and scientific notation. Okay, so these are the objectives here that I've outlined. Okay, we'll get to know what scientific notation is. I know you have an idea of it from your secondary school. And then we are going to look at the rules for counting significant figures. Okay, the rules for adding and subtracting two numbers that have different significant figures. And then we also look at the rules for, okay, so here it's a typing. I should have written for multiplying and dividing, okay, two numbers with different significant figures. And then lastly, as we go all through these, okay, we are going to solve exam common questions. All right, so let's start. So if you have any questions, please feel free to ask. So just unmute yourself and say, sir, I have a question here, and they will be able to explain. Okay, so we start with scientific notation. Okay, so what is scientific notation? So scientific notation is basically expressing a number in this form. So m times 10 to the power n. So this is what scientific notation is basically. Okay. So please mute your mics. For those who have their mics on, you'll be disturbing the class. You only unmute your mic if you want to ask a question. All right, so I was saying scientific notation is simply expressing any number that you've been given in this form here, where you have m, okay, multiplied by 10 to the power what? N. So this n here, it can be 1, a negative power, okay? Or it can be what? A positive power. So it can be negative there, and then it can also be what? A positive power. Okay, so the rule when you are expressing something in scientific notation is that this m here, or the number that you are going to put there, okay, should always be, okay, should always be greater than 1, okay, greater than 1, but less than 10. Okay, greater than 1, but less than 10. So the number that you have there, you should make sure that it is what? Greater than 1 and then less than 10. Okay, so if you are able to do that to a number that is there, okay, and then you multiply by 10 to the power some number which can be negative or positive, then we would say that that expression there is what? Scientific what? Notation. Okay, so to emphasize on this definition here that I've said that that number should be greater than 1 but less than 10. Okay, I'll write some numbers here and then I'll ask you if they're in scientific notation or not. So if I write 0.57 times 10 to the power 6, okay, and then I also write 57.4 times 10 to the power minus 5, okay? So are these two numbers here in scientific notation? Okay, we are going to say no. Why are we saying no? Because one, this number here is not greater than 1. Okay, it's not greater than 1. So it has broken this rule here that we defined there. Okay, and then even this number here below, it has 57.4 there. Okay, so 57.4 is greater than 10. So it has broken this rule that says that number should be what? Less than 10. So this number here and this number here is not, okay, is not a scientific what? It's not in a scientific notation. Why? Because this one here is less than 1, this one is greater than 10. But if I write a number like this, 2.7 times 10 to the power minus 5, we're going to say this number, yes, it's what? In scientific notation. Why? Because this number here is greater than 1 and it's less than what? 10. Okay, so we're going to be converting, okay, numbers from the normal form or the normal notation where it's just a number to scientific what? Notation. So now that I've explained this, okay, I need to explain the rules on how you can get the value of this n here. Okay, so we get the value of this n here by moving the decimal place either to the right or to the left. So when you move your decimal place to the right like that, it means the power that you are going to have will be what? A negative power. And then if you move your decimal place to the left like that, it means the power that you're going to have is going to be positive. So it's like they are opposite. If you're going to the right, the power will be what? Negative. If you're going to the left, the power will be what? Positive. So those are the two rules that we are going to be using there. Okay, so let us look at an example here. Okay, so if you have any questions, please feel free to ask. Just unmute yourself and then you can ask. Okay, so I've defined what scientific notation is. Okay, so for example, let us have this number here. So let's say I have 5,000 like this, and then they ask you, express this number in scientific notation. Okay, so whenever you see a number without a decimal place anywhere, just know that the decimal point is what? At the end there. Okay, so to express this in scientific notation, we are going to move this decimal place, okay, to a position such that the number that we are going to have will be greater than 1 but less than 10. Okay, so I'm going to say this is 1, 2, and then 3. So I've moved the decimal place to this point. So what I have now is 5.0 like that. Okay, and then I'm going to say times 10 to the power. Okay, how many times have I moved my decimal place? 1, 2, 3. So I'm going to write 3 here. And then now I need to decide on the sign that this 3 is going to have. Is it going to be negative or is it going to be positive? So if we move to the left like that, we say the power should be what? Positive. Okay, and then if we had moved to the right, okay, we have to say that the power will be what? Negative. So here we moved to the left, so it means the power should be positive, just like the way it has been there. Okay, so now we've expressed this number here in what? In scientific notation. Okay, so if you want, you can erase this 0 here. You can just write 5, okay, times 10 to the power 3. Okay, so that's how we convert from the normal form to the scientific notation. Again, you can also be asked to convert from this scientific notation to the normal form. Okay, so now let's convert this number to scientific notation. So 0.00674. Okay, let's convert this number to scientific notation. So what we are going to do there is we are going to move this decimal place until we have a number that is greater than 1 but less than 10. So I'm going to move this 1, 2, 3. So when the points comes here, we can see that the number that I'm going to have will just be 6.74. Okay, so it will be 6.74, and then I'm going to say times 10. Okay, and then how many times have I moved? I've moved 1, 2, 3 times. Okay, I've moved in which direction? I've moved to the right like that. So it means my power will be negative like that. Okay, so the power will be -3 there because we have moved it to the right. So that's how we can change from this normal notation, okay, to the scientific notation. Okay, it's just a matter of moving the decimal place such that the number that you have is greater than 1 but less than 10. Okay, so let's look at some more examples. Okay, let me just do 2 more examples and then we'll move forward. All right, so I know some of these things you learned them at your secondary level. Okay, so it's like a revision. So let's have 5.679. Okay, so the point is there. So change this into scientific notation. We are going to say we just have to move this place, this decimal point here, such that the number that we should have should be less than 1. Should be greater than 1 but less than 10. So I'm going to move this point 1, 2. So I've moved it 2 times. Okay, so if I move that 2 times, I'm going to have 5.5569 and then times 10. Okay, so how many times have I moved it? 1, 2, and I've moved it to the left. Okay, so I've moved it to the left there. So it means the power here will just be what? Positive like that. Okay. So this is what we get. And then let's do one more example on this scientific notation thing. So let's say 0.0, not zero there. Okay, 0.079, okay, 52. So express this in scientific notation. Okay, we are just going to move this decimal place until this number becomes greater than 1 but less than 10. So 1, 2. So a point to come there. So it will mean we have 7.952 times 10 to the power. How many times did we move? 1, 2. And we moved to the right. So it means the power there will be what? -2. Okay, so that's how you can change from the normal notation to the scientific notation. All right, so from there now we can talk about the rules for counting significant figures. So if you have any questions, please feel free to ask. Okay, just unmute your mic and then you can ask me. All right, so rules for counting significant figures. Okay, so the question should be, what are significant figures? Okay, so what are significant figures? Anyone who has an idea of what significant figures are? Anyone who can help us with the definition? Anyone? Okay, so significant figures are basically digits, okay, in a number or in a measurements that are known to be reliable or what? Certain. So meaning you are sure that that's the number that is there. Okay, so whenever you take any measurements, okay, maybe you find out the length of something, you say it's 50.5 meters. Okay, so this number that you get from measurements, okay, it always has a degree of uncertainty. Okay, so uncertainty will just simply a degree of error. Okay, so in this number here, there are numbers. Okay, there are numbers that are significant, and there are also numbers that are what? I mean, there are numbers that are certain, and then there are also numbers that are uncertain. Okay, so these first two numbers here, they're certain. And then that third number there is always what? Uncertain. Okay, so the last number. So the rule is that if I have a number, okay, the last significant figure in that number is always uncertain. Okay, so the last significant figure, not the last number, but the last significant figure. So for example, okay, I'll talk about the rules later, but I would just want to explain what the uncertain and the certain mean. So if, for example, I have 5, okay, 0.5 like this, okay, and then I have another number such that 5, 5, and then 0, okay? So we are saying the uncertain digit is the last significant figure in a number. So this number here, okay, we are going to talk about the rules. Okay, this number here has three significant figures. So it means the uncertain digit is this last one because it's the last significant figure. Okay, so it will be uncertain. And then in this number here, we only have two significant figures. This zero here is not significant. So it means the uncertain number will be the what? The last significant figure, which will just be what? 5. Okay, so I hope you get the difference between the certain and the uncertain digit. Okay, so the last significant figure is the uncertain. Okay, and then whatever remains on the left hand side here will be what? Certain. So here the 5 is certain, this 5 is uncertain. Here, this 50 here is what? Certain. And then this 5 here is what? Uncertain. Okay, so significant figures by definition, we are just saying that these are digits in the measurements or a calculation that are known to be reliable or what? Certain. All right, so there are about, is it 5 rules, okay, that you need to know when you are counting significant figures. So we are going to go uh, all through all of them, okay? So the first one, okay, the first one is that all non-zero digits, okay, all non-zero digits are significant. Okay, all non-zero digits are significant. So what does this mean? It means if you have a number that is not zero, okay, that number is what? Significant. So it can be 2, 5, okay, 7, maybe 7, 7, 6, okay. All these numbers here are significant. Why? Because they are non-zero digits. Okay, and then from there we are going to talk about three types of zeros. Okay, there are three types of zeros. So the first one is what we call as the leading zeros. Okay, leading zeros. So by leading zeros, we say the zeros that are appearing before a non-zero digit. Okay, so for example, this number 0.005. Okay, so these three zeros here, the ones that are appearing before this non-zero digit here are what we call as the leading zeros. Okay, so what is the rule concerning the leading zeros when we talk about scientific when you talk about significant figures, okay? So the rule is that all leading zeros are not significant, okay? So we count them as not significant. As long as it's a reading zero, okay? We call that as not significant. All right, and then the other type of zero that we have is what we call as captive zeros, okay? Captive zeros. So these captive zeros, okay, are just zeros between two non-zero digits. Okay, so if, for example, I write a number like 5005, okay, so you see that these two zeros here are between this 5 and that 5. Okay, so what does that mean? It means that these two zeros are captive. Okay, they're in between two non-zero digits. Okay, so what's the rule concerning such zeros? We are saying that they are always significant. Okay, so whenever you see captive zeros, just know that those zeros are what? Significant. Okay, as long as they are in between two non-zero digits. All right, and then the third one, okay, is what we call as let me use another color. Okay, so the third one are what we call as the trading zeros. Okay, so by the word trading, it means they come after, okay, the non-zero digit. Okay, so they come after the non-zero digit. So for example, if I write 2000, okay, so these zeros here are coming after this 2, which is a non-zero digit. Okay, so we are going to call these three zeros here as trading zeros. Okay, or it can be okay, it can be like this. Okay, 2 let me use the same example. It can be 2 and then uh, okay, 2 and then 000 like that. Okay, so these zeros are coming after a non-zero digit, so we are going to call them as what? Trading zeros. So on the trading zeros, there are two rules to consider. Okay, the first one is that if in that number where you have your trading zeros, okay, there are no decimal points, okay, or there are no decimal places, then we are going to say that these trading zeros here are not significant. Okay, as long as there's no decimal point that you can see in this number, then you are going to say that those zeros are not significant. Okay, but if it is shown like this, where you have a decimal point, okay, and then you also have trading zeros, then we are going to count those zeros as what? Significant. Okay, so trading zeros can only be significant if, okay, the decimal point is present. If the decimal point is absent, okay, we are going to say that those trading zeros are non-significant. Okay, so they only count as significant figures if a decimal point is what? Existing in that number. Okay, so those are the four rules that you need in order to assign how many significant figures are in this digit. Okay, such kind of questions. All right, so then let me write a certain number here, and then we identify the captive, the trading, and the leading zero. Okay, so this number is going to be this. So 0.00223005000. Okay, so in this number that I've written here, you can see all the three types of zeros. Okay, so these ones here, the ones that are coming before a non-zero digit, are what we say they are leading what? Zeros. Okay, and then these ones here that are between, okay, two non-zero digits, we say they are captive what? Zeros. And then the other ones there that are at the end, that are coming after, okay, a non-zero digit, are what we call as the trading what? Zeros. Okay, so what were the rules that we discussed? We said the leading zeros are never significant. Okay, never. They are never significant. We always uh, say that they are not significant. So we don't count them. And then the captive zeros are always significant. Okay. And then these trading zeros can only be significant if a number contains a decimal point. Okay. So we can see that in this number, we have a decimal point right there. Okay. So it means we are going to count these trading zeros as what? Significant. Why? Because there's a decimal point there. Okay, so if you just write 2000, this number here only has one significant figure, which is this one. Okay, these ones are not counted as significant, but immediately we introduce a point there like that, we are going to count these as significant. Okay, so the point can be anywhere within the number. Okay, it can be there, or we say that the point is at the end there. If they show it in the question, they put a point like that, we are going to say this number here as what? Both significant figures. Why? We're going to count the 2000. Why are we counting these zeros? Because we have a decimal point there. Okay, so those are the rules. So any questions there, guys? You are free to ask. Any questions there? All right, so there are no questions. Okay, so I'll give some examples here where we can be counting the number of significant figures that we have. Okay, I'm going to give some examples. All right, so let's write up a number here. Let's say, okay, let's say 2 has 0, 0, and then 3. Okay, so how many significant figures are in this number? Okay, so this number contains 4 significant figures. Why? Because I have these non-zero digits, which we always count as significant. Okay, and then I also have captive zeros. So we're going to say 1, 2, 3, 4. So this one here contains 4 significant what? Figures. Okay, and then what about this number here? Okay, what about this number that I'll write here? So let me just write a number with no zero like this, 7 and then 6. Okay, so this one here also has 4 significant figures. Why? Because all of these numbers, okay, all of these numbers here have a non-zero digit. Okay, what about this number here? Okay, let me say 4, 5, 0, 0. How many significant figures does this number have? Okay, we are going to see that it's just 1, 2. Okay, so these zeros, we are not going to count them as significant because they're trading zeros and there's no decimal point in this number. Okay, so we're going to say it has 2 significant what? Figures. Okay, what about this number that I'm going to write on top here? Okay, let me just erase this. So what about this number? So 0, 0.0 and then 450. How many significant figures does this number have? Okay, so we are going to say the leading zeros are never significant. This one is significant, this one is significant, and this zero is significant here because there's a decimal point in this number and it's a trading zero. So we have 1, 2, 3. So here there are 3 significant figures. So these are some of the questions that you're going to find in your assignment 1 or your tutorial sheet 1 for chemistry. Okay, and then what about this number here? Let me write it like this: 4, 5, and then 0, 0, and then make a point like that. Okay, so how many significant figures will be in this number? Okay, so because of the presence of this decimal point here that they have shown, okay, we're going to count these zeros as significant because they are trading zeros with the presence of the what? A decimal point. So we're going to say 1, 2, 3, and then 4. So this one here has what? 4 significant what? Figures. Okay, so it's very important to know the rules. Okay, what about 0.0 and then 45? Okay, all right, I think I wrote this already. Okay, but this one here will only have what? 2 significant figures like that. All right, so there are some questions, okay, that usually confuse students. So let me write down one of them. Okay, let me write down one of them. So we're going to say 12. No, let me not use let me use let me just use 1,000. Okay, so 1,000. So the question is, express this number, okay, as a number that has two significant figures. Okay, so anyone who has an idea of how we can convert this 1000, okay, which has one significant figures, to a number that has two significant figures. Any ideas there? What we can do? Hello, come on, guys. Any ideas there? How can we convert that 1000 to a number that will have uh, two significant figures? Because the way it is there, it only has one. But how can we convert it so that it has two significant figures?
You move the decimal place two places to the left.
Kindly come again. What are you saying?
You move the decimal two places to the left.
I think I can't get her. Anyone who is getting what she's saying, to just tell me.
She just said that you move the decimal place two places to the left.
Okay, she said we move the decimal place two places to the left. So if we move it, because this one here does not have any decimal point, so it means the decimal point is here, right? So if we move it 1, 2, the number is going to become 10.00. So this 10.00 here, how many significant figures does it have? Okay, this number here will have 4 because 1, 0, 0, and 0 are all going to be considered significant. Why? Because there's a presence of a decimal point. Okay, so I want someone who can tell us how, okay, we can convert this 1000 with one significant figure to a number that will have two significant figures.
I think you will round off to two decimal places, which will be 1 and 0, then put the point at the end.
Okay, so you're saying we round off and then we get 10, and then we put a point at the end. Okay, so if we do this, then it means we have changed the number, just like we did here, because this is 1000, but this will just be 10. So we have changed the number from 1000 to 10. So the number should still be 1000, but, okay, with the two decimal places. I mean, two significant
What if
figures.
we, what
What
if
is it?
we convert it to scientific notation?
Okay, exactly. So for you to achieve what I was saying there, okay, to convert this 1000 to a number that will have two significant figures, you have to change it to what? Scientific notation, okay? And that scientific notation will be in this form. Okay, so we are going to say this 1000, okay, if we write it like that, then, okay, we know that the decimal place should be at the end like that. So what we are going to do is move this decimal place, okay, 1, 2, okay. That can be the first way in which we can represent it as a number with two significant figures. So we are going to have 10, and then you can say point, okay, and then you don't write these two zeros, and then you say times 10 to the power. How many times have I moved? I've moved 2 times to the left, so the power should be 2 there. Okay, so if I multiply 10 point times 10 to the power 2 there, it's going to give me back my 1000 there. Okay, or, okay, you can write it in this form, which is the most preferred form. So if this question comes, you use the second one here that I'll use. Okay, you're going to say the decimal point is there. So I'm going to move it 1, 2, 3 times. Okay, so if you move it 3 times, you're going to have 1 point. And then of all these zeros that you have here, just write 1 0 like that. And then you say times 10. Okay, so how many times have I moved this decimal place to get to the place where I am? I've moved it 3 times. Okay, so this 1.0 times 10 to the power 3, okay, is in scientific notation, okay, and it is a number that has what? Two significant figures. And if we multiply this 1.0 times 10 to the power 3, we're going to get back our 1000. Okay, so this 1000 here can also be represented in this form like that. Okay, so this number here has exactly 2 significant figures. Why? Because this is 1.0. So if I have a point there, it means I'm counting this zero as what? Significant. So if they tell you express the 1000 as a number with 3 significant figures, it means you're just going to add another zero there. It will still take you back to the 1000 when we multiply. When they say express it as a number with 4 significant figures, you're just going to add another zero like that. Okay, it will be 4 significant figures here. All right, so those are some of the questions that you're going to be encountering when you have a tutorial sheet. Okay. All right, so let's now look at the next chapter or the next concept, which is the rule that we use when we are adding or subtracting
Hello?
two numbers. Yes? Someone has a question?
Yes, I do have a question, sir.
Yes, you can ask.
My question is concerning the first answer that you gave, 10 point times 10 to the power 2.
Yes.
Is it possible to leave a question, an answer like that, a point hanging without a preceding digit?
Yes, you can leave it whenever you are dealing with significant figures.
Oh, okay, sir. Thank you.
Yes. Okay. So the main thing that you want to show is that you can express that number in exactly the number of significant figures that they have told you to. Okay. But
Okay.
the most preferred one is this one that I was explaining in the second place there.
Oh, okay.
Right. So now let's go to this rule here that says the rule for adding or subtracting two numbers, okay, that have different significant figures. Okay. So how do we add those numbers? So we have rules. Whenever you have addition or subtracting, you use a certain rule. And then whenever you are multiplying or dividing, you use a certain rule. So you're going to see these questions in your tutorial sheet 1 or assignment 1. Okay. So let's say, for example, I have these two numbers here. Okay. So 2 and then point 2. And then I'm saying plus, okay, 4.002. Okay. So we can see, since we've discussed how to count the number of significant figures, okay, we can see that this value here has how many significant figures? 2 significant figures. It's just this one and this one, okay? And then this value here, okay, it has how many significant figures? It has 4 significant figures, okay? So it means these two numbers here have different significant figures. So now, what is the rule concerning such situations where you are adding two numbers with different significant figures? Okay, because what you've been exposed to is just the normal number. So let's say 5 and then plus 6. Okay, you're just going to get 11 there. Okay, so we have rules that we follow when we are adding numbers that have different number of significant figures. Okay, so whenever you are adding or you are subtracting, the rule is that once you add those numbers, okay, once you add those numbers, the final answer should have the same number of decimal places, okay, as the number that had the least number of decimal places. Okay, so that's the rule whenever you are adding or you are what? Subtracting. So let's add these two numbers. So I have 2.2 and then I have 4.002. So when we add these numbers, okay, of course, you guys are just going to be using a calculator to add in chemistry, okay? But be mindful that in math, there is no calculator. So this is 202, and then here there's what? 6, okay? So this is the number that I get when I just add these two numbers, okay? So now, how do I represent my final answer? So whenever you are adding, you look at the number of decimal places that those two numbers that you are adding have, okay? Or when you're subtracting, it's the same thing. So this first number here, it had how many decimal places? It had 1 decimal place. Okay, we can only see this one here. And then this second number here had 1, 2, 3. So it had 3 decimal places. Okay, so the rule is that when you add these two numbers that have these two different decimal places, okay, your answer should have the same number of decimal places as the number that had the least. So this one here had 1 decimal place. So it means when I add, my final answer should also have what? 1 decimal place. So once you add like that, you need to round off this number such that you have 1 decimal place. So when we round off this number to 1 decimal place, we are going to get 6.2 like that. Okay, so this here will be our final answer. Okay, what if we are subtracting? Okay, when we are subtracting, we use the same rules. Okay, we look at the number of what? Decimal places. So for example, if I have 8 and then minus 4.2.5, I mean, and then 7.6. Okay, so this number here, you just punch them on your calculator. Okay, so when I punch this on my calculator, what am I getting? Okay, so I have 8 minus 4.576. So when I subtract that on my calculator, I'm finding 3.4 and then 24 like this. Okay, so the rule is that your final answer should have the same number of decimal places as the number that had the least number of decimal places. Okay, so we see that this 8 here has how many decimal places? 0 decimal places. And then this one here has 3 decimal places like that. Okay, so what will this mean? Okay, it means that our answer should also have 0 decimal places. So we are going to round off this number such that it doesn't have any decimal places. Okay, so if we round off this 4 here to this 3, since this 4 is less than 5, this 3 remains the same. So we're going to say the final answer there will just be what? 3 like that. Okay, so the final answer there is 3. So whenever you're adding or subtracting, make sure that your final answer, okay, make sure that your final answer has what? The same number of decimal places as the number that had the least number of decimal places. Okay, let's look at another question. Okay, let me write something here that is a bit of complicated. So we have 12, 1, 2.5, and then plus 6, 7.2, and then plus 409.02 like that. Okay, so we want to add these numbers. Okay, so whenever we add these numbers, the final answer should have the same number of decimal places as the number that had the least number of decimal places. So you just get these numbers and punch them on your calculator. Okay, so it's chemistry, we don't have to suffer. So 212.5 plus 67.2 and then plus 409.02. Okay, so when I add that on my calculator, it's giving me 688.72 like this. Okay, so now our final answer should have the least number of decimal places. So when I look at this number, how many decimal places do I have? 1 decimal place. If I look at this number, I also have 1 decimal place. If I look at this number, I have 2 decimal places. Okay, so it means my final answer should only have 1 decimal place. So we're going to round it off from here like that. So if I round off these 2, since it's less than 5, this number is going to remain the same. The 7 here is going to remain the same. So it means our final answer will just be 688.7. So this here will be our final answer. Okay, and whenever you are subtracting, you use the same rule. Okay, all right, so if you have any questions there on the addition and subtracting of two numbers that have different significant figures, okay, you can ask. Okay, so if there are no questions, let's go to the next question now. Okay, let's go to the next question or the next part. Okay, so the next part here, I should have written multiplying and dividing. Okay, so that was an error there. So let me just correct it. So the rule for multiplying, okay, multiplying or dividing. All right, so what is the rule for multiplying or dividing two numbers that have different significant figures? Okay, so the rule is that the final answer, okay, once you do your multiplication or your division, okay, the final answer should have the same number of significant figures as the number that had the least number of significant figures. So we've switched. When we're talking about addition and subtraction, we said we are looking at the number of decimal what? Places. But here, when we are looking at multiplying or dividing, we now look at the number of what? Significant figures. Okay. So for example, let's have 2.02 and then times 2. Okay. So when we multiply this 2.02 times 2, we are going to get 4.04. Okay. This will be our final answer. So the rule is that the final answer should have the same number of significant figures as the least number between the two. Okay. As the same number of significant figures as the number that had the least number of significant figures between the two numbers that you are multiplying. So this one here has 3 significant figures, but this one here has only what? 1 significant figure. Okay, so it means that my final answer should be a number that has only 1 significant figure. Okay, so when we round off this, our final answer here should just be 4. So 4 is just 1 significant figure. Okay, the same as the number that had the least number of significant figures. Okay, so that's the rule that we use whenever we are multiplying two numbers that have different significant figures. Okay, so let's do some example here. So let's say we have let's say we have 57.09, okay, and then times 1.0 000. Okay, so when we multiply this, what are we going to get? Okay, when we multiply this, what are we going to get? So when we multiply this, okay, what we are going to get is, okay, let me put it on my calculator. So I have 57.09, then multiplied by 1.4 zeros there. Okay, so what I'm getting is this number. So 57.09 and then 0, 0, like that. Okay, so this is the number that I'm getting. Okay, but what will be my final answer? So you look at the two numbers that you are multiplying. This one here has 4 significant figures. And then this one here, how many significant figures does it have? It has 5. Okay, significant figures. Why? Because the one is significant and all these zeros here are significant because they come after the decimal places, the decimal point here. So these ones are trading zeros and there's a presence of a decimal point. So they become significant. Okay, so this one at 5, this one at 4. So it means our answer should have what? 4 significant figures. But the way it is, this number here, it has 6 significant figures. So we need to cut it there. Okay, so if I round off this 0, it's not going to change anything. So we are going to still remain with 57.09 like that. So this here will be our final answer there. Okay, so it's the same thing when we are dividing. Okay, you just follow the number that has the least significant figures. Okay, so for example, if maybe we have 5.75, then divided by, okay, 6.123. Okay, so what are we going to get there? So let's divide. So I have 5.75 divided by 6.123. Okay, so I'll be getting this number 0.939082 and then 1493 like that. Okay, so this is the number that I get. So how am I going to determine the correct answer? Okay, so you check the numbers that are involved. So here I have 3 significant figures. And then down there I have 4 significant figures. So it means my final answer should have 3 significant figures. Okay, so when I look at this number here, what can I do to it for it to be 3 significant figures? I'm going to round off from here like that. Okay, so if I round off from there, it means the 0 will round off to this 9 here. So since this is 0, it's less than 5, so nothing will happen to the 9. So what we're going to have will be 0.939. So this here will be our final answer, and it has 3 significant figures, just like the number that has the least number of what? Significant figures there. All right, so those are the rules. So please
Sir,
always,
I have an issue.
yes.
You said the final answer will be 0.939. What if we round off the 9 at the end to the 3, then it becomes 0.940?
What if we round off which number?
Would that be wrong? Since 9 is 9 to 3, so that becomes 0.940
Okay,
because 9 is
so
greater than 5.
you're saying we round it off from here?
No? Yeah, like we give 9, we give 1 to the 3.
Yeah, like we give 1 to the 3 and then we get 0.940. Okay, so we can't round
Would that
off.
be wrong?
Yeah, it will be wrong because it will be like you've changed the number a little. Okay, if the number was ending just here at 9, then you can be allowed to do this. But this number continues to go like that. So what you are doing in getting this answer is that you are ignoring this part. Okay, you are saying this part does not exist, but this part exists. Okay, so we can't go that direction. So you go there like that, and then you round off.
Think so.
All right, so those are the rules that you need when you are dividing and multiplying two numbers that have different number of what? Significant figures, okay? So it might not come as a question the way I'm presenting it here, but you have to use it, okay? When you are solving, when you're finding those moles, whatever you'll be finding in chemistry, even in physics, you need to be using these same rules, okay? All right, so let me just give another one example and then we'll be done for today. Okay, be done for today. So I'll give an example that involves all the rules that we have discussed when we are adding, subtracting, and multiplying and what? Dividing. So let's say I have 7.05 minus, okay, 3.1 times 10.6. Okay, and then divided by 16.37. Okay, and then I'm saying
Sir,
yes, plus
sorry for interrupting, sir.
4.51. No, you are not interrupting. You can ask.
Going back to the question of the previous one we had, where we had 0.939. So if we had, for example, 0.93445, and then they say round it off to three decimal places. So that would be on the fourth, between 4. So does that mean
Yes,
can we
between
round
here.
off the 5? Yes. Can we round off the 5 and give the 1 to the 4 and then round off the 4? Since it becomes 5, we round it off, it gives the 1 to the 4.
No, you can't do that.
Also, you just go direct where they say this.
Yeah, you go direct where you're supposed to round off from.
Okay, sir.
Yes. All right, so what if we have this question here that I've written down here? Okay, so we can see that in this question, we have the minus sign, we have the positive sign, we have the multiplication, and we also have the division. Okay, so how are we going to solve that? Okay, let me even make this number maybe bigger. Let's say okay, let's say 5, 9, like that. Okay, so in this question here, we have all the rules that we need to use, like all the rules that we've learned. Okay, so where are we going to start from? Okay, we are going to use your board mass, if you still remember your board mass. Okay, so this says the brackets of division, multiplication, addition, and what? Subtraction. So we are going to start with what we have in the bracket. Okay, and then we are going to go to division, and then if there's a multiplication, we're going to go to multiplication, and then addition, and then finally what? Subtraction. So that's what we're going to do. Okay, so let me even make these numbers like that. All right, so we start with what we have in the brackets there, okay? So it means we are going to have 7.051 minus, and then we deal with what we have in the brackets, okay? So you just get your calculator, you say 3.1 multiplied by 10.6. So the answer that I'm getting there is 32.86. Okay, so what's the rule when we are multiplying two numbers that have two different significant figures? We said the final answer should have the same number of significant figures as the number that had the least number of significant figures. So from here, we see that this 3.1 had 2 significant figures. And then this one here had what? 3 significant figures. So it means our final answer there should also have what? 2 significant figures. Okay? So what we are going to do is that we are going to round off from there. So this is 8 here. So if I round it off, it's going to become what? 3 there because it's greater than 5. Okay, so it means what I have in the brackets here, if I multiply and then I follow the rules for the addition of 2 different numbers that have different significant figures, I'm just going to get what? 33. So what was in the bracket here has turned into 33, and then divided by, I still have this 16.3759, and then plus, okay, and then I have this number 4.51 like that. Yes? The one who has raised the hand, you can ask. I've seen someone has raised the hand. Oh, maybe it's a mistake. Okay, but this is Muwowo Dexter. You had raised your hand. All right, so that's there. What we have in the bracket there, we have gotten what? 33. Okay, and then from there, we've dealt with what we had in the brackets. The next one, okay, will just be what? Division. So we have to deal with this part first. Okay, so this part here, just go on your calculator and then you type these values like that. Okay, so I have 33 divided by 16.3759. Okay, so when I divide that, I'm going to get 2.0151564189 like that. So this is the number that I'm getting. Okay, so what is the rule when you are dividing numbers that have different significant figures? Okay, so this one here has 2 significant figures, and then this one here had 1, 2, 3, 4, 5, 6. There's 6 significant figures. So it means my answer should also have what? 2 significant figures. Okay, so how am I going to make this number to have 2 significant figures? I'm going to round off from this point here. So if I round off this 1 to this 0, it's not going to change because the 1 is less than 5. So it means the number that I'll get for this part here where I'm dividing, once I follow the rules, okay, it will just be 2.0. 2.0 has 2 significant figures. Okay, so it means this part here will just become a 2.0. So let's erase what we have on top here. Okay, so we are going to have 7.051 and then minus it. So this whole part that we had there, where we are dividing, it has become 2.0, and then I still have plus 4.5 what? 1. Okay, so this is what we have. And then from there now, we are still, remember, we're still following board mass. Okay, so board mass, we've done the brackets, division, multiplication. We're now on addition. So we're just going to add these 2, these ones here. Okay, and then we subtract finally. So let's add those. So when we're adding, we said the number should have the same number of what? The answer should have the same number of decimal places as the number that had the least number of decimal places. So this one here, the 2.0, has 1 decimal place. And then this 4.51 here, it has what? 2 decimal places. Okay, so that one adds 2 decimal places. So we are adding this 2.0 with this. So what are we going to get? Okay, so I'm going to say 2.0 plus 4.51. So what I'm getting is this one is still there, 0.051. And then I'm going to say minus, okay, when I add this and this, I'm getting 6.51. Okay, but this answer should have 1 decimal place. So it means I'm going to round it off from there. So if I round off this 1, this 5 will just remain the same. Okay, so we are going to have 6.5 like that. All right, so any questions there before I proceed? All right, so there are no questions there. So let's. All right, so sorry about that. I think the network was performing right. I got kicked out of the meeting. Okay, but we can proceed. So I was saying here, okay, when we add those two numbers, the answer that you should get should have one decimal place. Okay, so this is what we got, 6.5. And then the last part now will just be subtracting this and this one. Okay, so if you subtract that, so just punch them on your calculator. Okay, so you have 7.051 minus 6.5 like that. So if I subtract that, I'm getting 0.551. Okay, so this is what I'm getting. So remember, the final answer should have the same number of decimal places as the number that had the least number of decimal places. So this one here has one decimal place. This one here has three decimal place. Okay, one decimal place like that. Okay, so it means we have to make this number to have one decimal place. So we're going to round it off from here. So when we round it off from there, what are we going to get? 0.6, because this 5 here will add a 1 to this 5. So the final answer there of that whole expression that we had will just be what? 0.6. Okay, so any questions there on whatever we've done today? Okay, feel free to ask any questions there on whatever we've done.
It's clear, but I want to ask about the when it comes to rounding off, there's what they call rule of 5, where the number that you want to round off, if it is a 5, and it involves even number and odd number. Can you explain a little bit, sir, on that?
Yeah, so they don't really follow that at once, but I know the rule that you're talking about. So if a 5 is followed by an even number, it remains the same, and then if it's followed by an odd number, then you have to round off. Yeah, so they don't follow that at once. So you just get the general pick. So if it's 5 or more, just round off, and then if it's 5 or less, you don't round off.
Oh, thank you very much, sir.
All right. So thank you so much, everyone, for attending. We'll continue the classes. Okay, so we've started today. Tomorrow, we are also going to start to continue. So I'll share the timetable with you. Okay, we have each day we have 2 sets of classes. Okay, the other one will be starting at 19 to 20, and then the other one will be starting at 20:30 to somewhere 21:30. Okay, so be free to interact with us. We are here to help. Okay, if you have any questions, you can ask us. And if you have any study material, if you want any study materials, okay, you can also inbox me. I can share some study materials. I think I shared the link in the group. So that link has materials for all the NSS that you can think of in Zambia. Okay, so it has files for all the universities. So when you click on it, okay, just make sure you go to the folder for UNZA. Then you'll be able to find the data there. There are past papers, story sheet notes. I think even lab report samples are there, so you can check them out. Okay. So as I said, our classes will be free for 2 weeks. Okay. So this week and next week, the classes will be free. And then afterwards, those who want to continue learning with us, you can register with us. So when you register, you're going to create an account on our website. So this is our website that you can see there. Okay, so we have math, chemistry, physics, biology, just like that. Okay, so when you open this course for, let's say, math, okay, you're going to find 2 folders. Okay, so don't go in this folder. This is specifically for those who are at Apex. So for you at UNZA, you go in the general mathematics here. Okay, and then you're going to find 4 folders here. So we have lessons and tutorials. So if you go in the lessons and tutorials here, you're going to have all the topics that you're going to learn. So you can see we have the folders for every topic. Binary operations, whatever you're going to learn at UNZA. Okay, we have them here. So in these folders, there are videos, okay, and there are also notes, okay? So you can watch a specific topic that you want. Maybe say you don't understand binary operations. You just go in the binary operations there, okay? And then you're going to find the slides, notes, and the supplementary. You're going to find slides and notes, recorded tutorials, and supplementary tutorials. Okay, so if you open the recorded tutorials, you can see the tutorials that we have there. So you can watch any of them to understand the concept about binary operation. Then when we go to the slides and notes, you're going again to find the notes there. So you can read, okay? You can read whatever you want so that you understand. And then when you go to this part, we have supplementary tutorials, okay? So we have some supplementary tutorials, videos that we upload there, so to help you understand, okay? So that's what we have on in the lessons and tutorials. And then when you go to, okay, I've gone back a step further. Okay, if you go to the handwritten notes here, you're going to find well summarized handwritten notes. Okay, they are there just waiting for you. Okay, so if you want to read about set theory, they will be there. Well explained notes. Okay, so you can access them there. And then there's also this folder for tutorial sheet and assignments. Okay, so when you come to the tutorial sheet and assignments, you notice that there are different universities here. So you go to the university that you belong to. So if you're at UNZA, you go to the tutorial sheet for UNZA. Okay, and then you're going to find written solutions and video solutions. Okay, so you can open any of them and then you can be able to learn like that. Okay, so you try to solve the questions and then you compare with the solutions that you have. So here we have Math 11 20. Here we have Math 11 100 solutions, handwritten. Okay, so you can learn from them. And then if you want, you go to the videos. You're also going to find the videos that we'll be uploading as we learn together with you. And then what else? I think I should show you also the past papers here. Okay, so the past papers, we also have the same setup. So you go to your university. So you are at UNZA, you go in this folder for UNZA. You open it and then you're going to find written. So if you go to the written solutions, you're going to find written solutions for the previous years. Okay, so in this first document here, you can see I wrote 2013 to 2021 past papers. Okay, written solutions. So you can go through, and there are also some quizzes that you have, some tests. There are written solutions all over in this folder here. Okay. Okay, and then what else do I want to show you? Okay, there are also exam papers. There are exam papers here. Okay, yeah, so we have the 2022 exam here, full written solutions, and then I also have the 2023 there, written solutions. Okay, we are yet to upload last year's exam. And then if you want, you can go to the videos. Okay, if you want, you can go to the videos here. You're going to find the videos. Okay, so here I have 2022 and 2023, and then here I have 2024 exams. So the exams for last year. Okay, these are the videos there. So you can only access this from our website, and you can only access this website once you register. Okay, so but for the free classes, you'll be able to learn. All of you will be able to learn. Okay, but for this website, you only get there once you register, so that you can be able to access all these here. Okay, and then on this same website here, hey, what is happening now? On this same website, when you register, you're going to find this icon for WhatsApp groups. Okay, so here you're going to be a WhatsApp group for registered members. So you just register using the same website and then you join the group, the WhatsApp group. And then there you have YouTube channels. Okay. So there's 3 YouTube channels there. There's this one for me, Tutor Pro Solutions, you can see it. Then there's Tutor John, and then there's Math with Marius. Okay, and then we are also going to add another one here. So if you go to my YouTube channel here, I think most of you have seen it because I was sharing some videos. So this is my YouTube channel here. You can find videos on a lot of different concepts in math, in whatever. Okay, so you can go to the playlist here. Where's the playlist? You can click on the playlists and then you'll be able to find the playlist. I organize them like in a very organized way. So you can learn from all this. Okay, so that's what makes our lessons unique, because we have notes, we have everything that you need in order to pass your exams. Okay, so our lessons are strictly online. We don't have any physical lessons. Okay, I should mention they are online. Why? Because online learning, you can learn at your own time, you can learn at your own pace, you can learn from anywhere. You won't have any risk in case you come from a far boarding house from campus. Okay, you won't have any of those risks that you need to move back to your boarding house after the tuitions. No, You can learn right there in your blankets, okay? You can just be learning on the phone. All right, so this has been Tutapo Solutions. Thank you so much for attending the lessons. The lessons continue tomorrow, and I'll share the timetable and this video after the class.
Hello.
Yes, you have a question?
There is no summary.
There's no what?
Summary. Like, can you summarize what you have taught?
I've already done. I've already done. So, did you start the class? So if you
Yeah?
didn't start the class, I'm going to upload the recorded video so you can actually rewatch it.
Okay.